Quantum Optics for Engineers is a fairly unique book. It is designed for engineering students with a background on first-year calculus and first-year algebra. Quantum Optics for Engineers does not use sophisticated mathematical techniques. In this regard, the emphasis is entirely on the physics. Another intrinsic characteristic of quantum optics for engineers is that it is designed to describe the whole of quantum optics from the perspective of Duarte's notation. Therefore, the presentation provided is unified and quite coherent. Also, Quantum Optics for Engineers provides a very interesting and unique description of the synergy between the principles of quantum optics and the principles of classical optics from an interferometric perspective. The book is fairly well self-contained with nearly 500 pages, 190 illustrations, and some 1,000 equations. There is no need for the student or the reader to run to the library, except when some particular topic, of course, needs to be or is wished to be studied in greater depth. The Duarte notation in Quantum Optics for Engineers is introduced in a fairly transparent and methodical manner, and once the ideas are very explicitly explained, the same infrastructure is used to derive the interferometric equation, which is a generalized interferometric equation either in 1 dimension, 2 dimension, or 3 dimensions. But for practical purposes, the 1-dimensional interferometric equation can then be used to describe all the principles of optics, that is, all the main principles of optics as in an orderly fashion, from interference to diffraction to refraction, and then finally to reflection. Now, that might be surprising to some, but that's how nature works. Once the principles of interference are fairly well introduced and displayed and exemplified through a number of exercises, the attention turns to polarization, both classical and quantum. And then the door is open and all the tools are there to explain and describe the equation which is the basis for all the present technological advancements in quantum optics and, let's dare to say, in optics. And that is the probability amplitude of entangled states of quanta propagating in different directions. That equation, that probability amplitude, is the Price-Ward-Snyder probability amplitude, which was introduced by John Ward back in 1947. Now that might also be a surprise to many readers. The approach that is used is the Ward approach. Also an alternative Hamiltonian approach is utilized, and a fairly transparent and methodical interferometric approach. Once all these tools are made available, all these armamentarium of physics, then the emphasis turns to the description of topics of very much present interest, that is interferometric communications, quantum communications, quantum entanglement, quantum cryptography, quantum teleportation, quantum computing, and quantum non-demolition experiments. Now, the very last chapter in the book is a chapter on issues of interpretation, because historically this subject matter has been, let's say, entangled with all those topics. And the interpretation that we have chosen, very much appropriated for an engineering description, is the very pragmatic interpretational approach shown to us by Dirac, Feynman, John Ward, and Willis Lamb. I'm pretty sure that you will like it. If you would like to know more about quantum optics for engineers, since after all this is a very, very brief introduction, please search in the web or visit Quantum Optics for Engineers at www.opticsjournal.com.